Arithmetic of fractions.
Fractions obey the general commutative, associative, and distributive laws of arithmetic, which are the fundamental laws of basic arithmetic. Therefore, fractions can be multiplied, divided, added, and subtracted.
We shall start with the multiplication of fractions. Let's say we have to multiply the fraction 3 over 4 by 2 over 5. This can be demonstrated using boxes. Let's create 4 vertical boxes representing the denominator 4 in the fraction 3 over 4.
Let's also create 5 horizontal boxes representing the denominator 5 in the fraction 2 over 5.
If we shade 3 out of the 4 vertical boxes, we would have represented the 3 over 4 fraction.
And if we shade 2 out of the 5 horizontal boxes, we would have denoted the 2 over 5 fraction.
To obtain the total number of boxes, we multiply the two denominators 4 and 5 to give us a grand total of 20 in all.
Also, to obtain the total number of shaded boxes, we multiply the two numerators 3 and 2 to give us 6 shaded boxes out of the grand total of 20 boxes.
This means that the two shaded boxes out of the horizontal group of 5 is multiplied by the 3 shaded boxes out of the vertical group of 4. Similarly, to obtain the grand total of all the boxes, the 5 total boxes in the horizontal group is multiplied by the 4 total boxes in the vertical group.
Please note that this concept of boxes is for explanation purposes only. We do not have to always draw them whenever we execute multiplication of fraction. Simply put, 3 over 4 times 2 over 5, which is equal to 3 times 2 equal to 6, all over 4 times 5, which is equal to 20.
To multiply fractions, multiply numerator by numerator and denominator by denominator independent of each other. That is 3 over 4 times 2 over 5 equal to 3 times 2 over 4 times 5, which is equal to 6 over 20, and which represents numerator over denominator.
However, you can reduce the fractions to their lowest terms before multiplying. This process is called cancellation. In the fractions of 3 over 4 times 2 over 5 earlier discussed, 3 over 4 by itself is in its lowest terms, and so also is 2 over 5. But since the numerator of one of the fractions and the denominator of the other fraction are divisible by the prime factor of 2, we can afford to reduce them to their lowest terms before multiplying. That is, 2 into 2 to give 1, and 2 into 4 to give 2. Therefore, 3 times 1 equals 3, and 2 times 5 equals 10. By this process, the final result is 3 over 10. If we did not reduce the fractions to their lowest terms, we would have ended up with 6 over 20, which will still be reduced to 3 over 10. However, reduction before multiplication is usually easier than cancellation after multiplication.